Hello everyone and welcome to Unit 1, Analyzing One Variable Data. So what is statistics? Now, over the summer, you guys should have done a summer project and you should have learned a little bit about this and how it could possibly relate to you in your future studies. But statistics is actually the science and art of collecting, analyzing, and drawing conclusions from data. Now, data, doesn't really matter how you say it. I might switch it up depending on what we're looking at. But a little fun fact is that the plural of data is actually data. Okay? If you're looking for the singular, it's datum. Now, this is why you might see things like those data or other words that kind of allude to that it's more than just one. It might actually seem really weird to say data in the future. You're going to see a lot during the examples, but I just want to let you know that data is actually plural. If you want the singular, it's actually datum. So the statistical problem solving process, the first thing you want to do is you want to ask questions. Okay, and when you're asking questions, you're clarifying the research problem and asking one or more valid statistical questions. Okay, you want to collect data, okay, in the statistical problem solving process, design and carry out an appropriate plan to collect the data. You want to analyze the data or use appropriate graphical and numerical methods to analyze the data. And then the last thing you want to do is interpret results, which is also one of the most important things, because why would you be doing this in the first place if you were not going to make conclusions based on your data? So what you're going to do is you're going to draw conclusions based on the data analysis and be sure to answer the research question. I can't tell you how many times that at the end of the entire process, people don't go back to the question and answer it. Okay, so make sure you always go back and answer the question. Okay, so today we're going to be looking at part A, which is classifying and summarizing data. So the first thing I want to talk about is individuals. And individuals are objects described by a set of data. They may be people, but they may also be animals or things. Now, there are many other ways to classify these things. We have observation units. You may have seen these names. You may see cases. You may see subjects when they're people. Or you may see experimental units. Okay, so these are all different words that you may hear instead of individuals, but I want you to make sure that you can go back and make the connection between the two. Okay, so a variable is any characteristic of an individual. So whatever describes the individual is a variable, and they can take on different values with different individuals. Okay, we have categorical variables, which places an individual into one of several groups or categories. And we have quantitative variables, which take on numerical values for which arithmetic operations such as adding and averaging make sense. Okay, now there's a couple other words for these. We can also call categorical variables qualitative data. And you'll actually see these used a lot in the social sciences, but qualitative and categorical mean the same type of variables. We also have some kind of like breakup for this quantitative variable. We have two different things. We have discrete variables, which are things you can count. And we also have continuous variables, which are things you can measure. Okay. And you have to know one really important thing. quantitative comes with numbers, but you need to know that not everything that has a number is considered quantitative data. Because remember, quantitative data is data that makes sense to average or do numerical operations on. Couple things that are numbers that are not quantitative data is things like your license numbers or your zip codes or your phone numbers. It doesn't make sense to find an average phone number, but you still have a long list of numbers. Or your zip code. It doesn't make sense to add up a whole bunch of zip codes. Okay, so those are two examples of categorical data that actually have numbers, and a lot of people kind of confuse the two. So just again, not all numbers are quantitative variables. Most are, but not all are. So let's go into an example, because I always think that an example helps the most. So we're going to look at example number 1, and we're actually going to look at the table and label the data below with the new vocabulary we just learned, okay? So the first thing I want to do is I want to find individuals. My individuals in this case, this table here displays several roller coasters that have opened since 2014, and these are actually all real roller coasters and real statistics. So it's kind of interesting looking at this. But first thing we want to do is we want to find the individuals. So what are we looking at? What are we measuring? What are we really trying to find out things about? And that would be the individual roller coasters. So these roller coasters here are the individuals. Okay, so the roller coasters are the individuals. Okay, the next thing we want to look at is what are the variables? And remember that the variables just measure the things about the individuals. So the type of roller coaster, the height of the roller coaster, the design, the speed, and the duration, these guys right here are all variables. Okay, now more specifically, we have two different types of variables, right? We have categorical and quantitative. So let's look at this. Is type of roller coaster categorical or quantitative? Well, it's a type of something, so it's actually going to be categorical. Okay, let's look at height. Now notice that these are all numbers, right? Does it make sense to add and find the average height for all the roller coasters? Yeah, you can totally do mathematical operations with these numbers. So this is actually going to be quantitative. Okay. We have the design. Is it sit down? Is it inverted? These are different categories of design. So this is categorical. And notice, please, that I am not writing out the full words. You can do the same, or you can write them all out. It's up to you. And then we have speed and duration. Now, both of these have numbers, and it does make sense to find average speed and average duration of rides. So because these are numbers and it makes sense to do mathematical operations on them or arithmetic operations, these are both quantitative. So quantitative. These are both quantitative. There we go. Okay. And so again, we have individual roller coasters. The things describing those roller coasters are variables, and then the type and design are both categorical, and then the height, speed, and duration have numbers that make sense to have arithmetic operations with, so those ones are quantitative variables. Okay, so we have different ways of describing all of this data, and the first one is the distribution of a variable. And that tells us what values the variables take on and how often it takes these variables on. Okay. Ways to summarize a distribution. We have a frequency table, and a frequency table shows the number of individuals having each data value. Again, we're going to be doing a couple examples with these. So if you're like, oh, what's a frequency table? Don't worry, we're going to look at them. And a frequency table can either show, it shows count. Okay. And then we have a relative frequency table, and that shows the proportion or percent of individuals having each data value. Okay. So this one shows more of a proportion. Okay. And I also do want to go back up to distribution for a second. I just want to tell you that distribution describes the pattern of variation in variables. So I'm going to write that out here because I think that's a really important term. So distribution describes the pattern of variation in variables. Now that's a tongue twister. Okay, and what it's saying is, like, how much does it change from one thing to the next? Okay, so let's do an example. Oh, the distribution of a variable describes, oh wow. I guess I could have just waited for that, huh? So example number 2, okay? Let's go to example number 2. We have one of Mr. Tyson's statistics classes was recently asked if they prefer a pasta party, a pizza party, or a donut party. I wish I had Mr. Tyson. Maybe we can have a pizza, pasta, or donut party later in the year when it gets a little bit more safe to do so. So here are their responses, which surprised their instructor. Okay, so again, I believe there's 30 here. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So there are 30 students here, and there are their ways of how they answered the question of how they wanted the party. So we have summarized the distribution of preferred party with a frequency table and a relative frequency table. Okay, so the first thing we're going to do here, I'm going to use the right mouse, okay, is we're going to make a frequency table. Okay, so what I'm actually going to do is I'm going to draw out a table, okay, as nice as I can make it. You'll see that drawing skills are not my forte, but that's okay. So this is going to be the preferred party. Okay, and we have pizza. Oh, we'll do donut. And then we'll do pasta. And then we'll do pizza. Let's do it in alphabetical order. Okay. And what we're going to do first is we're going to do what the frequency is. So what is the count of each? So let's look at donut first. We have 1, 2, 3, 4, 5 donuts. So the frequency of donuts is 5. Okay. Now let's look at pasta. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Wow, that's a lot of pasta. And actually, that surprises me too. A lot of kids would want a pasta party over a donut or pizza party. And then the last thing we have is pizza. And you can see that we have a pizza here. 1, 2, 3, 4, 5, 6, 7. Now, I always recommend, because we know that we have 30 kids here in this class, I always recommend to make sure that your frequency adds up to that number. So 18 and 7 is 25, plus 5 is 30. So this right here is our frequency table, okay? Now, it also asks for a relative frequency table, and you can actually kind of combine both of them together if you want to. You could have it separately, or you could have them together. But what I'm actually going to do is I'm going to put my relative frequency table in with this table here. So what does this mean? Well, we're looking for either a proportion or a percent. So we could either say that it's 5 out of 30, or we could actually find the percent for that. And let me just put that in a calculator real quick. That's going to be 16.7%. So 16.7% of the students in Mr. Tyson's class would want a donut party. Now for pasta, we have 18 out of 30, which when you put in a calculator is 60%. So that means that 60% of Mr. Tyson's class wants a pasta party. And last but certainly not least, we have pizza, which is going to be 7 over 30. Okay, which when you put it into a calculator is going to be 23.3%. And again, all of these numbers here add up to 100%, which is what you're looking for. You should always check for that. But what does this mean? It means that 23.3% of Mr. Tyson's statistics class would prefer a pizza party. Okay? So here on this graph right here, you can see that I try to organize it just a little bit better so you guys could see it at home. What does this tell us about what we're looking at? It means that more than half of the class preferred a pasta party, making it the clear winner. A pizza party was the second most preferred party, but the number of students who chose the pizza party, or 7 students, was less than half of the number who chose the pasta party at 18 students. And again, only 5 students chose the donut party, which was the least popular choice. Part B, displaying categorical data. So we're going to talk about different ways to display categorical data. So the first way we want to talk about is a bar chart, which shows the category as a bar. The heights of the bar shows the category frequencies or relative frequencies, so their count or their percentage. And my cat is now yelling at me. Okay, a pie chart shows each category as a slice of the pie, and the areas of the slices are proportional to the category frequencies or relative frequencies. Okay, so example number 3, who wants to party with frequency? So below is the frequency table of the preferred party for the 30 students in Mr. Tyson's statistics class. Now we just did this one in example number 2, so I hope it is still fresh in your brain. So what we're going to do is we're going to make a bar graph and a pie chart to display the data, and we're going to describe what we see. Okay, so we have this little bar over here, and what we're going to do is we know that the number of students goes from 5 to 18. So what I'm actually going to do is I'm going to go by 2s here. So 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. And I'm going to graph those. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. And these are going to be the number of students. And again, this little symbol right here is more than just a little hashtag. It's also a number system. Oh my gosh, a symbol. It's an octothorpe. It's a pound sign. You could write out number of students. I'm just being, I guess, a little lazy. Okay, and down here, you're going to have the preferred party. Okay, and remember, we had 3 types. We had the donut party. We had the pasta party. And we had the pizza party. Okay, so what we're going to do is we're going to show the frequency on the left side. So what we're going to do is the donut party had 5 students. So what we're going to do is we're going to draw a line at 5 and draw them both down. Okay, the pasta party had 18 students. So we're going to draw a line right here, and we're going to try to make these the same width. Try to be as accurate as possible. Obviously, we're doing this by hand, so it's not going to be 100% perfect, but just try your best. And we're going to talk more about why we have to make sure we do that in a couple minutes. And then the pizza party had about 7, so if we go across, we come down here, and this is your first bar chart. Okay? As you guys can see, the pasta party was the clear winner here, followed by the pizza party, and the least preferred, the donut party. Very easy to see these numbers. We made sure that we started at 0 over here to make sure that nothing looked a little off. But now we want to make a pie chart of this data. Okay, so what we want to do here to do the pie graph is it's actually really useful to look at the relative frequencies. Okay, and remember that the relative frequencies was 16.7%. We had 60%, and we also had 23.3%. Okay, now when we're actually trying to graph a pie chart, you always want to find the center. Okay, and I always like to start off by drawing a line here. Now you can draw that line anywhere, it doesn't have to be there. And the first thing we're going to do is we're going to look at our donut party. Okay, how many people want to do the donut party? And that was 16.7%. Now, how are we going to find out how many degrees this number here relates to in this circle? So we know that the circle is 360 degrees. The whole circle has 360 degrees. So this donut was 16.7% of 360 degrees. Now, you can't write 16.7 in like that. You have to write it in as a decimal place. Okay, so it's going to be 0.167 times 360, and that's going to give you 60.1 degrees. Okay, so now we need to measure what 60.1 degrees looks like. Okay, and I'm just going to graph what I think 60.1 degrees looks like. Now you guys can get out a compass. You could be using some sort of software. You could be doing a whole bunch of different things here. Excel makes beautiful pie graphs, but if you're going to be doing it by hand, it's really useful to know this knowledge. Okay, so this right here is donuts with either, you could say 5 or 16.7%. Okay, it actually gets a little easier doing the other two from here because now we know what we're doing. We know that, and I like to save the biggest one for last, and you'll see why in a couple seconds. So next thing we're going to do is pizza, and that's a count of 7, but it also has a percentage of 23.3%. So what we're going to do is we're going to multiply 360 degrees by 0.233 or 23.3%, and we're going to get 83.9 degrees. Okay, now 83.9 degrees is just a little bit smaller than 90 degrees, so we can come over here. It's just a little bit bigger than the other one. This is going to be pizza with a count of 7 or 23.3%. And again, you don't need to write all of these things. You can either write the count or the percentage. It's really up to you. Now, last but certainly not least, we have pasta. Okay, and we know that pasta is 60% or 0.60% of 360 degrees, which when you put in a calculator is going to be 216 degrees. And if you look at the space that we have left over here, that is 216 degrees. So we're actually going to write pasta in here, okay, with a count of 18 or 60%. Okay, now again, you don't have to do these by hand more than once or twice throughout the whole year. I might ask for 1 or 2. I think I'm going to ask you to do it in your homework by hand just to give it a shot. I just think it's important to see it by hand, but most of the time you're just going to be able to use some sort of online tool or Excel in order to do these because they make them much easier and much prettier. No offense to anybody that makes perfect ones. So things you need to look out for. You need to look out for scale. It's super important. I have an example of that if I could find it. If you look at these right here, it's actually the same data, but if you look at the scale of the one on the left, you see how it starts off at 0.4 and ends at 0.5. It makes it look like the New York Yankees got a lot more victories than the Boston Red Sox. It looks like they actually maybe got 4 times the amount of victories the Boston Red Sox did. Okay, but we know that it's not even 0.1%, right? If you actually look at the numbers. Now, if you look at the right one, they start the scale off at 0, and you can see now that the Yankees only got a little bit more victories than the Red Sox. Okay. We also have to look out for misleading pictographs. Now, we didn't really cover pictographs. It's probably one of the first graphs that you guys looked at when you guys were learning about anything statistics-wise. Here's an example. It's just instead of a bar or anything like that, you're going to be seeing a picture. So if you look at this here, I mean, you can kind of tell what's going on. You can, if you're looking at it. But the problem here is that the pasta one looks really misleading because the pizza and the donut, they're so much wider than the pasta that looking at this immediately, you might think that the pizza or the donut might actually have been the preferred party because the pasta is so thin. Okay. Now, a way you could have done this is maybe you could have made bars with little pictures of donuts or pizzas or pasta inside the bars. I don't really know how making these thinner would make it look very strange. So maybe this wouldn't be the best pictograph to do. Maybe this wouldn't be the time to do a pictograph. But because the pasta is so tall and skinny, it's really misleading on which one is really the preferred party. Okay, and again, something super important for everything is that everything must have a key. Okay, so back when we were doing our little pie chart, Another preferred way of doing things is to have colors instead of writing in the pie chart. If you were to do colors and say like red was equal to pizza, we would have to show somewhere in a key that red was pizza. Okay? Now, this ends part B, and what you're going to be doing now is you're going to be looking at the homework assigned. And if you guys have any questions or concerns, please don't hesitate to either email me or you guys can show up for the class time Google Meet. Okay, I hope you guys will have a fantastic day.